Okay, I'll try to take it a bit slower for you guys. So we're focusing on cast iron. Having a look, by definition, a steel never contains more than 2% carbon. So we know that steel is an alloy of carbon and iron. So it doesn't contain more than 2% carbon. But when you get more than 2%, usually 3 or 4, that's where it starts to become a cast iron. And those pans that I showed you earlier, like a cast iron fry pan, that is an example of cast iron. It has different properties to steel because it's a different alloy. Here are some advantages of cast iron. So that will help you with some of your questions today. Okay, and I'll give you time throughout this period to answer those questions. Now, here are some of those alloying elements in cast irons. So we know cast iron is an alloy already, so it's an alloy of carbon and iron. But now, an alloying element is an element that adds on to cast iron. So these are some of the things that are added onto cast iron in the mixture when it's all molten and melted to make it even have better properties. Okay, so by adding these, you'll add extra properties that make it even better to be used. So I'll give you a quick summary of each of these. So carbon, well, okay, carbon's already in it to make cast iron. And some of the properties include that it's more useful with good machinability. You should be seeing my screen right now. You should be seeing the table in front of you. Tensile strength and toughness. Silicon is actually really important as it enhances its vibration absorption, so it is more resistant to vibration. And if this last sentence is something to note. So the greater the amount of silicon, the less cementite. So remember those black lines, those thick black lines in the microstructures, and more free graphite. I'll get to this in a sec. Less cementite, meaning that's not as brittle, because cementite is brittle. Manganese toughens and strengthens iron. Sulfur makes it more stable, and I'm not too sure what stable means. I imagine that it's less prone to brittleness, and also but has side effects as well. And phosphorus improves fluidity, low strength applications. Okay, so what you need to know for this is a lot of information to take in. The main thing you need to know is just the alloying elements, mainly silicon. Okay, mainly silicon. The amount present, not entirely necessary. This textbook does give too much detail, but the main thing is just that cast irons, what they're made from, its advantages, alloying elements, and as for the effect, just the silicon will do. Okay, hope that's clear. Now moving on to page 116. Okay, there are different types of cast irons. So just like timber, just like wood is not all the same. There's oak, there's pine, there's maple, there's many different things. Just like cast iron, there's many different types. So all these italic headings, white, gray, high duty cast iron, spheroidal graphite cast iron, these italic headings, these are different types of cast irons. So that's one of your questions. So now, in summary, white cast iron, what we need to know for each of these, just need to know its properties, and its properties will do for now. Okay, some of them you'll need to know, it gives you a bit more specifics of what it looks like, so how it looks like here as a microstructure. and also what it's made of. So 3 things: what it's made of, its microstructure, so how to draw it, and also its properties or advantages. So here it's malleable. Structure is merely perlite and cementite. So here you go. And advantages: wear resistance. Grey cast iron. So here's its microstructure. Let's look for the advantages. So advantages: it's easily machined, so it's easily used. Machines, it's able to be worked pretty easily. And also, what other properties? Excellent vibration dampening. Okay. So those are advantages and also properties. Now, something you want to know is these small graphite flakes. So when I mentioned silicon allows for free graphite, what I meant was these small graphite flakes. So these little graphite flakes, this is what these are just flakes of graphite. And what that means, if you have a look, these flakes are essentially voids in the structure, which make the grey cast iron weak in tension, however strong in compression. So the effect of these flakes is that it's weak in tension. Remember, tension is pulling apart, compression is pushing in. And to reinforce that point, pearlitic grey cast iron exhibits good toughness, good compressive or squashing strength.
Sir?
Yes, yes.
Before you keep going, would you explain margin please? I didn't get that.
Margin side, okay. Is it okay if I could do that towards the end? I'm happy to do that with you personally or with anyone that wants to know that. Is that okay?
Yeah.
Cool. Okay. And okay, now moving on. Now, when you look here, we've now got ferritic grey cast iron. Okay, we see these large graphite flakes are a lot larger, okay, as compared to this. So they're bigger, they're pointy. Think of them as like big cornflakes just stuck together. And this black line around here is the grain boundary. So that grain boundary is all ferrite, and with voids or sections of large graphite flakes. Now, let's think about it. If silicon produced this small graphite flakes, how is this produced? How is large graphite flakes produced? So silicon produced this small graphite flake. How is large graphite flakes produced? Well, quite simply, it's through adding more silicon content. So by adding more silicon, you'll have a larger graphite flake, which would result in, imagine, more compressive strength, however, with a greater, with less tensile strength. Right. Okay, and we go through that here a bit more. So the graphite flakes are essentially voids in the structure filled with graphite, which has little mechanical strength, and they have sharp edges and ends. So this means they act as stress concentrations at the tips of the flakes, and under tensile strength yet pour up. And under a tensile load, cracks can develop. This is why grey cast iron develops good compressive strength yet poor tensile strength. To improve the tensile strength, there are cast irons where the graphite forms into a rounded clump instead of a flake. So let me explain that a bit more. You should be seeing my paint program. For some reason, the whiteboard is not working for me. we have, let's just say we have a pencil, so it's a pencil there, and it's sharp. Okay. If I exert a lot of pressure at this point here, right here at that point, then it's going to break, because all the force is directed onto that one point. However, if my pencil now becomes blunt, but blunt, it's not sharp anymore, then the stress is spread out across this whole section, across all of this, instead of being focused on that one point. So because of those sharp tips, then that's why cracks can develop. Now, because we don't want cracks to develop, have a look at this sentence. In spheroidal graphite cast iron, this is like an improvement upon the previous one, is a cast iron that replaces the sharp edge graphite flakes with rounded globules. So instead of having those sharp edges in ferritic gray cast iron, we now add small amounts of magnesium when it's molten or melted to create these round shapes. Okay. So these round shapes here. So now it now has tensile strength double that of fine gray cast iron. So this has better tensile strength as compared to this, because those sharp edges are no longer there. And where is it used? Well, okay, it's used in brake discs and drums. So again, this is a lot of information. Let me just simplify it. What you do need to know is just these microstructures, the difference between each one. You should be able to draw each one. And how was this achieved? From this. Quite simply, it's through adding magnesium, okay, or cerium. Just remember these two. And why? Because we want to increase its tensile strength. Where is its use? In brake discs and drums. So these are things you need to know. Okay. 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 Compacted. Okay, there you go. Now, spheroidal graphite. Spheroidal graphite is this one down here. Compacted graphite are these. Okay. So these technical terms and these numbers, you don't need to know everything, but it's just there to just give a bit of a picture. Okay. I'll show you what to read. Now we'll look at this first before we look at the table. Compacted graphite cast iron. So that's this one here. What we notice is that it's still rounded-ish. It's not as sharp as the sharp flakes, but it's not fully rounded. It's like in between. So this is most round. This is like half round, half sharp. And then this is like really sharp. Yes, okay. Okay, so think of it, have a look here. This compacted graphite cast iron is a compromise, so an in-between between spheroidal graphite and gray cast iron. So this and this one, and gray cast iron, this one. So it's an in-between, it's the compromise. CG cast iron has magnesium, cerium, and titanium alloy added. Now it has titanium added. What titanium does? It doesn't allow the graphite to form fully round doesn't allow it doesn't allow it to become fully round, but instead it only allows it to become short, stubby, round flakes. So now it's like an in-between, So have a look. If you look at the vibration dampening capacity, the grey cast iron has a really good dampening capacity. So this one here, as I mentioned, when you add silicon to this, and lots of silicon, it actually has a really good vibration dampening characteristic. So back to this part here, if you can see my mouse, excellent vibration dampening characteristic. That's because of the silicon. Okay. This one here has some vibration dampening characteristic. This one has a lot of vibration dampening or vibration softening. So gray has a lot of vibration softening. With spheroidal, it doesn't have very much dampening capacity, so this one here, whereas this one here has an in-between. So it's kind of best of both. Alright, okay, I'm going to, alright, okay. I think that's a lot of content to go through. I'll leave it at that for today. I won't go through the rest.